Hi guys, welcome to the third video in the tutorial series in which we're going to be covering state machines as well as temp blocks and what was it again? Moving entities, that was it. Alright, and we're going to be doing that by creating a move called water pool. What it'll do is it'll allow a water bender to select a water source, then left click to shoot out a stream of water, which will basically grab an entity or a target that it collides with and then pull them back towards the source. So yeah, that's what we're going to do. I've gone ahead and set up the two main classes that we're going to need, a listener as well as the main class, and I've populated the load and stop method, set the sneak, harmless, cooldown name, get author version, all that's boring stuff, so I don't have to waste your time on that. And then let's get started. We're going to start off in the listener, and we're going to need two listeners, the on sneak and on click, because how this is going to work is you sneak at a block to select a source, and then you left click. Oh, we're also handling sourcing this tutorial. You sneak on a source, and then you left click to launch it. So that means that we need to listen for two interactions. So, but we're going to start off with this on sneak. And what we're going to do is we're first going to check if the player started sneaking, not they stopped. So we're going to grab the player. And how this event works is that it runs before you actually execute the action that fired the event. So if I were to check if player is sneaking here, this would be false because I am not actually sneaking yet. But this event has a special method to handle that. Which is basically the opposite of player is sneaking. So if we are sneaking, but I actually want to check if we're not sneaking. So if we're actually going up, then we return, because then that's one of the conditions in which we don't want to start the move. What we're then going to do is we're going to grab the bending player. We're going to say bending player, get bending player. And if that bending player is null, we're gonna return, and then we're gonna say if bending player can bend, and then we're gonna say core ability water pool class. We're gonna say new water pool. Now I'm actually gonna teach you a little nice optimization trick here, which is called dependency injection. So what we're gonna do is we're gonna create a constructor here, water pool, and we're water pool listener actually, and we're gonna say we're gonna pass a value to that constructor called water pool. And what we're then gonna do is we're gonna say create field. There we go. And what we can then do, instead of doing core ability get ability here, which is a pretty heavy call, you should know that calling this a lot is not very good. It's pretty heavy. So what we instead do is when we create our listener, in here, we're just going to pass this instance of the class to it, which means that we can just use that instance all the time to see if we can bend it or not, which is much more efficient. All right, so we got the water pool going here, and yeah, so we can bend it. All right, that's cool. Then we come in here. Now let me, I've actually wrote this move before, and I recorded it and everything, but I didn't like the quality of the video, so I decided to just start anew. So what we're first going to do is we're going to find a source block, because if we're actually not sneaking at a valid source block, we don't want to do anything. We don't even want to cancel other active instances. I've also gone ahead and imported all the constants that we will need for this move. You can just add them on the way. So there's a special method called get water source block, which will return a block or null if there was no source where we were looking, and we pass the player the range at which we can select the source and whether or not the player can plants are allowed. So if we don't find a block, so if it's null, we return like this. Okay. What we then do, actually I prefer it with braces. What we then do is we're going to check if there's already an existing instance of water pool for this player, because if that's the case, we want to cancel it, because we don't want when you sneak at a source for water pool, and you select that source and a sneak at another source, the previous source needs to be cancelled. So get class, and if there is an existing one, we're not gonna cancel this move, but instead we are gonna we're just gonna remove the old one and then continue. So at this point we've done all the things that we need to do. So we're gonna save the source block in a class variable because we need to use that a lot. We're gonna create a location which will be at the center of our source block, and when you get the location from a block, it'll always be like in the corner. So we add half a block on each axis to get the location to the middle. So let's go ahead and actually create variables for that. Block, source block, private location. All right, cool. And what we then do is we're gonna create a list of temp blocks. Now I'm gonna make this a linked list. I'll explain the why in a bit. And we're gonna say list temp blocks. Now this list will basically be a list that contains all the temp blocks that we have placed. And I've made it a linked list because I think, and I'm not sure yet, I'm gonna judge that in a bit. Excuse me. We're gonna see it in a bit because I think we're gonna be adding and removing a lot more from the list compared to getting by index. What the difference between an array list and a linked list, allow me to explain that real quick, is an array list is very good at finding items at a certain index, so the get method, but it's not very efficient at performing the add and remove methods. Now linked list is the other way around. It's very efficient at adding and removing. No matter how big a linked list gets, it will always, the performance time for add and remove will always be the same. And but it's not very efficient at getting. The larger the list it gets, the heavier the get method will be. Now, it does actually, right now it doesn't really matter. If you use an array lister instead of a linked list, it's not like your server would freeze up. It's just something that I, as a long time programmer, always keep in the back of my head. Well, a longer time programmer, I'm sorry, keep in the back of my head. So it just kind of comes natural to think about that. But honestly, if you find that to be a bit overwhelming or too much to think about, don't worry, an array list will cut it. Doesn't matter. It really doesn't matter. All right. So, and then we're gonna create a new variable called state, and actually gonna do that in a bit. All right, we're gonna start on the state machine. What we're gonna do is we're gonna create a new enumeration in here. So private enum, and we're gonna call it state. I'm gonna assume you know what an enumeration is. If you don't, I advise you to look it up. They're not hard to use or learn at all. They're very easy. It's basically a list of constants, that's all. And what that's gonna be is this enumeration is gonna contain all the possible states for our move. And now you might wonder, all right, what's a state? Well, it's actually very easy. The first move we made, Pyromancy, I think it was called, doesn't have a state. It exists in an instant and is removed in an instant. It does something and then immediately goes. Its effects remain visible over time, but the move itself doesn't. So the blast move, on the other hand, has a single state. We left click, it springs into existence, it travels forward until it meets one of its removal requirements, and that's it. Then it gets removed. That's a single state. However, especially moves with source selection usually have more than one state, and our move has three actually. The first one being a source has been selected, the second one being traveling forward, and the third one being pulling back in. So let's actually write those. We say state source selected, the second being traveling, and the third one being pulling. Now we'll use these states to differentiate or to determine in which state our move currently exists. So we're going to say private state, and when we create a new move, we want to start off in the source selected state. And what we're gonna do in the progress method then is first we are gonna create an if statement here to see if the player can no longer bend or move. Because if that's the case, we want to remove. Actually, I guess a remove with cooldown, which I'll get to in a bit. And then we say or if the player isn't sneaking anymore, because I want the player to keep sneaking throughout the entire move. So we're gonna say first quickly we're gonna say private void remove with cooldown, which will basically call the remove function and add a cooldown. There we go. All right, so what we're gonna do here is we're gonna say switch state. I'm also gonna assume you know what a switch statement is. Well, okay, if you don't, it's basically a fancy way of writing a bunch of if-else statements. And then we say create missing branches. So we have a separate branch for each of the enumeration entries: source selected, traveling, and pulling. So in here we say, if we're in the source selected, we say progress source selected. And here we say progress traveling. And here we say progress pulling. And then what we're going to do is we're going to say create method. Create method. Create method. And I'm actually going to put these above the progress method. There we go. Now, when we're in the source selected, actually, let me swap these around. When we're in the source selected state, this progress method runs. When we're in the traveling state, this one runs. And when we're in the pooling state, this one runs. And now we don't have to touch, like, we don't have to make if-else statements checking what the state is with booleans and stuff and then perform stuff in that if statement. We just have 3 separate methods for each state. So clean, it can't get any better than this. This is a state machine. All right, so when we just have a source selected, we want to play the focus water effect at our source block. Now this will play that that smoke animation that you're probably familiar with if you're a waterbender. And then what we're going to check is we're going to check if our source block, get the location, get distance or distance squared towards our player. So the distance squared between our player is greater than the source range. Now, we've done this before in the blast move, but we're doing distance squares and not just distance, because the distance method uses the Pythagoras theorem, which basically means that it'll use a square method, the square root method, which is a pretty heavy thing to call every 20 times a second. So what we instead do is we use distance squared and then just multiply the source range by itself. So if the player has walked away too far from their source, we remove it. We don't put it on cooldown, just remove it. And not only that, we're also going to throw in an if state, an or statement. If the source is no longer water bendable, we say we're also going to pass player, because let's say our current player doesn't have access to ice bending, but the source actually became ice. This will make sure, oh, okay, ice is water bendable, you're right, but this player can't ice bend, so it'll still return false. So that's okay. All right, so that's it for the source selected state. Now we're gonna get into the more interesting stuff, the traveling one. So for this, we are actually first gonna go back into the listener, the on-click listener. And what we're gonna do is we're gonna get the player that clicked. No, yeah, we are. Get player. All right, and what we're then gonna do is we're gonna say get action. How I usually do this. Nah, okay, let's do it the proper way. We're gonna say action is left click block, or event get action is action left click air, and I made a typo here. And if that's the case, then we want to continue. So what I'm actually gonna change this. If the action is not left click block and it is also not left click air, then don't do anything, because we've right clicked or stepped on a pressure plate and then we don't want to activate the move. All right. So the next step here is to see if there is an active water pool ability for this player. So how can we do that? We can do that by doing core ability, get ability, player, water pool class. Now you might wonder, but didn't you just say we don't have to use get ability anymore because we already injected it in here? And yeah, you're right for when we use can bend, but we don't want to do that now. We want to get an ability for a specific player. We don't want to get like the information instance of this ability. We want to get like an active instance of this ability for a given player. And that's what this method does. It finds an instance of this ability for this player. All right, so we found an active instance of this ability for this player, and the fact that it has an active instance of this ability means that they are on the right slot and everything. So what we then do is if water pool is not null, we say water pool on click, and that method doesn't exist yet. So we're gonna go in here, and above the progress method, I'm gonna say public void on click, and now this method gets called when we left click. There we go. And basically what we do, if the current state is source selected, then we are going to upgrade the state to traveling, and we are gonna initialize our direction. Now we're not just gonna say player, we're not just gonna do player get location get direction like this, because this only works if the move you are launching, like the location, is the player, but it's not the player, it's being launched from a source. So if you were to launch this in the direction the player is looking in, it would always have an offset and it would never hit the place the player clicked at. So what we're instead going to do is we're going to use a method from general methods called get direction, and it'll be from the current location, which is at the source currently, and then wherever the player is looking. So for that we use general methods get targeted location, we say player and then range, and then we normalize this. Actually, let's see, does it already normalize it? It does not normalize it. And then we multiply by the speed. There we go. Then progress traveling. What we're going to do in here is we're going to move the location towards our target. So first off, like with the blast move, we're just going to say location at direction. What we're then going to do, okay, so what we're then going to do is we are going to gather all the I'm gonna think if this is actually useful. All right, now what we're actually gonna do is let me see in here. Yeah, well, before we get into the temp blocks, we're also gonna keep track of our distance traveled. So let's create another variable here, just like with the blast move. Distance traveled, and there we go. All right, so what we're then going to do is we're going to check if location, or no, I'm sorry. Yeah, this is a little thing that I added in my previous version of this, and I want to add it again. If the location is currently in water, yeah, if it is, so let's say, so we're our current location is traveling underwater, so we can't see our temp block being placed, and so we can't see our temp blocks being placed. What we're then gonna do is we're gonna say location get world spawn particle, and we're gonna say particle dot water bubble. At our location, let's spawn 8 of them with an offset of half blocks each with no speed. And now this is gonna give an error saying this might be null. I don't know why it says that. Let's just add a null check here, I guess, just in case. All right, so when our move travels underwater, it'll spawn some water bubbles. Turret actually does that too, so I figured why wouldn't we? All right, what we're then gonna do is we're gonna check if we've bumped into a wall. And we can do that with general methods is solid, location, get block. Now, when working with water, it doesn't really matter, but when you're working with like truly solid blocks, this might become a problem. What if your move, your code, detects your temp blocks, like the block you placed as part of the move, as a wall? What you're going to do about that? I'm actually going to handle it. I don't know if it actually matters with water, ice, and leaves. I'm just going to act like it does and program us in a solution for it. So first off, we're going to check if the block at our current location is a temp block. All right. If it is, we do this. If it doesn't, if it's not, we do this. All right, so it's not a temp block. Okay, then let's check if the block we have collided with, so location get block, is not our source block. If it's not, okay, we've actually hit a wall and we want to return. Actually, normally you would say like remove here, but I don't want the entire move to just go away. I want it to pull back in. So what I'm gonna say here is state pulling instead of remove. Okay, but what if it was a temp block? Well, let's grab that temp block, because there's temp block get, so we can get the temp block at the location of any given block, if there is any. Then we can say if temp blocks contains our temp block, this means that yeah, we hit one of our own temp blocks, but we want to check if we haven't hit one of our own temp blocks. If we haven't, we change the state to pulling, we reverse the move, and that's the end of it. So this is how you would do that. All right, then we go to next, and now we're actually gonna draw our temp blocks. So what we're gonna do is we're gonna say list block. I'm actually doing this a bit different than I did before, so I'm trying to decide what the best course of action is here. Yeah, okay. I got a cool idea. We say we get all the blocks along a line. So we get blocks along line, which the method will make in a bit. We say get all the blocks on the line from source block get location add, so the center of our source block, to our location. So get all these blocks. And we're gonna create the get blocks along line method right now. So we say private void get blocks along line. And I actually already wrote it. But I am going to just write it again to explain it to you. You could use a block iterator from Spigot here, though I'm not too familiar with it, so I didn't want to dive into it. I just used code that I already knew. So first off, we're going to clone the from location, because we're going to be transforming it, and I don't want to mess with it in case you because if we mess with this variable in here without cloning it, it'll be edited outside the method as well. So what we're going to do is, after that, we're going to get the vector between the from and to location. And normalize that, because we have to in this scenario. And now we're going to create a list of blocks, which will be our result. So actually we're going to create a linked list, I think, or an array list. Hard to say. Let's go with an array list, because we're going to have to do the contains thing quite a bit. And then we're going to say, while our from location is more than one unit or one block away from our destination location, so more than one, we want to continue finding blocks. So if the result does not contain our this block yet, we say, okay, so if it's not in there yet, and then we say result at from get block, and then we move from towards the to location, and then finally we add the final block to the result, and then we return the result. This needs to return list of blocks. All right, so now we've written a method that returns a line of blocks, and what we're going to do now is we're going to say, all right, so this might seem a bit like weird to some people, but I have a reason for, hold on, I'm actually trying to think of. All right, yeah, so what we're going to do is we're not just going to set a temp block at our location, because what I want to do is, let's say the speed of the move is actually more than 1. So per tick, it travels more than 1 block forward. What could happen is that it starts at like 1 block, like this. It starts in this block, and then it totally skips this one, and then it ends up in this one, the move. But this one wouldn't be set to water because it just skipped right over it. So what we're going to do is we are going to say for I equals, now I have to think for a bit. If there are 3 in there, I wanted to start at 3. So yeah, okay. What we're going to say is temp blocks size, as long as I is smaller than line.size, I plus 1. So we're going to loop through the difference in blocks between temp blocks and line. So let's say there are 3 blocks in temp blocks. Temp blocks, again, is the list of temporary blocks that we have placed. So there are currently, the line exists of 3 temp blocks, and our location has moved forward, and then we get all the blocks along the new line, and those are 5. So what's going to happen is I is going to start at 3. This code is going to run. Then it moves up to 1. It's going to be at 4. This code is going to run. It's going to move up 1. It's going to be at 5. It stops because 5 is not less than 5. And then we have placed 2 temp blocks. So what we do is we say block on line. We say line get I. There we go. And then we say temp blocks add new temp block. Block on line. And then we say here material water. All right. Now that's it for the temp block animation. And this might sound a little complicated, and I agree. It is complicated. Temp blocks aren't a very easy thing, like blocks in general aren't a very easy thing to deal with. And there are a lot of edge cases that you need to think about. This is one of them. And there's actually another edge case currently that we've programmed into the move, because if the move is faster than 1 block a tick, what if it like clips through a wall or something? That's also something you need to keep in mind. To prevent that, what you could do is instead run this method, not in there, but in here. So we say, we don't say location get block, and I haven't tested this before. I don't know if this will work, but we can try it. We say block online. Block online, block online. There we go. All right. And then after we've drawn our temp blocks, we're gonna try to find a target. And how we're gonna do that is we're gonna say general methods, get entities around point, and then we give the location and the size of our hitbox radius, which is 1.5 blocks right now. And then we're gonna, this will return a list of entities, but I am actually gonna use a little cool trick called a stream. And what that is, a stream basically turns a list into, it keeps it a list, except that you can now chain a bunch of methods to apply logic to that list. So what we can do is we can say filter, and then let me see what you have to create it normally in here, a predicate. Let me go ahead and actually say we created something called an anonymous class in here, new predicate entity like this. And then there's the test method, which basically gets an entity, and I can throw in some logic here that would then be applied to that list. And only the elements in the list that return true here are kept. So what I do is instance of, I say return instance of living entity. Oh, entity like this. So now only the entities that are an instance of living entity are kept. And I also want to say entity get unique ID is not the player, because we don't want the move to be able to pull the player itself. All right, but this is like a bit big, long, a lot of code. So what you can do, and this is the coolest thing in my opinion, with a anonymous class, you can turn it into something called a lambda. So replace with lambda, bam, it becomes this. It just says entity and then an arrow, and this is where you put like what you would normally put in an if statement, or just your Boolean logic. You say if this entity is an instance of living entity and this entity's unique ID is not the player's. And now we filtered out all entities which are not a living entity, and as well as the player. But now the stream still contains a list of entities and not living entities. So what we're going to do is we're going to map it. And what happens when we map it is that we are able to transform the type of object that is in this list. We are able to perform logic onto each element in the list so that we can transform it. So we're gonna perform a cast to each and every single one entity or element in this list. So now we've cast living entity to every single element in this list, and then we're gonna say find first. So we find the first element in the list. All right, hold on, my doorbell's ringing. Right, I'm back. It was instant for you, but not for me. So yeah, we use the find first method to get the first entity in the list, and then that returns something called an optional of living entity. And an optional is basically kind of like a container, kind of like I don't know if you know it, but if you know the theory about Schrodinger's cat, which is a pretty cool thing in my opinion. It's basically Schrodinger's cat is like there's this box, and this didn't actually happen, it was a theory. There's a box, and in there is like a sort of time bomb, something that will release a potent like a poisonous gas between 5 seconds and 5 hours. And there was also a cat in there, and the theory was, where was I? Oh yeah, the Schrodinger's cat theorem. So basically what it is that anywhere between those 5 seconds and 5 hours, that cat could be dead from the poisonous gas or not. And you don't really know which one until you check, which is exactly what an optional is. We don't know if after we've applied our filter and stuff, and even if in the first place there was anything in our list at all. So when we say find first, we get an optional, and we don't know if there's anything in there. So we have to check. So we have the isPresent method. If you use get, but there's nothing in it, you're gonna throw an error. So don't do that. But what we are gonna do is we're gonna say if our potential target is present, so if we have found a target, or if our distance traveled is greater than our range, so we've moved out of range, we set the target to potential target, or else we're not going to use get because this might be false, so there might not be a target, but we might have traveled out of range. So if we used get, then it would throw an error. So what we're going to do is or else. So get the value of our potential target, but if there isn't any, use this null. And then we're gonna start change the state to pulling, and then multiply the direction by -1. Actually, I am not doing that. We're gonna do something different. We're not modifying the direction at all. So in here we say private living entity target, like this. And that's it for the traveling method. Now we get into the pulling method. So previously we added the direction. Now we're going to subtract it. That's it. Subtract. We don't do the distance traveled stuff because it can never move out of range. It's moving backwards. So yeah. Alright, so what we're now going to do is we are going to get a list of blocks along our line again. So we say get blocks along line. And then from the source again, add to get the center, and then towards our location. And now what we're going to do is we're going to say, alright, so if the blocks in our line is less than the temp blocks we have currently shown, we want to remove all the temp blocks. We want to remove all the temp blocks that are not in our line. So how we can do that is we're going to use the same kind of for loop again. We're going to start at the size of line, and then as long as I remains lower than the size of temp blocks, we increase. And what we do is we say temp blocks, remove at I, and then revert block. And there we go. So when you remove by index, it actually returns the object that you just removed, and then we revert that block. All right. Then what we do, as long as the target is not null, so if the target is not null, we're going to check if the target is still in the same location as the world, as our move, because if it's not, it's gonna throw a bunch of errors. I've had it happen before. So you might wonder, when is this ever the case? But it can actually happen quite a bit, because what if you are being pulled by this move, and while that's happening, some admin on the server teleports you to another, like the spawn world or something. I'm just naming random stuff. It would try to pull you towards a location in another world. It can't do that. So then we say target null, and if they are in the same world, then we are gonna run the pooling logic. So I'm actually gonna add some additional logic here. If target is dead, yeah, that. Wait, I think we should also add another check here, and I'm actually just gonna throw in an if else, because otherwise it would get too messy. So else if target instance of player, and gonna cast that, so player target is online, so they are no longer online. Then we also set the target to null, and if all of these things aren't true, then we perform our pooling magic. So what we're going to do is we are basically going to find, so first off, we're going to find the direction between our target and the location of our move. So we use general methods get direction for that, from the target's location towards our location, like this. So towards our move location, and then we're going to check if the length of that vector is smaller than 0.2. So if they're actually already very close to our move, then we don't want to move them at all. We just want to hold them still, because otherwise they will get jumbled around a lot. So we say null vector, which will be a constant up here, private static final vector null vector, which is just an empty instance of vector, which will set it to 0, 0, 0. All right, but if it is further away than 0.2 blocks, then what we're going to do is we're going to set the target's velocity to our towards location but we are also going to normalize and multiply it by the speed of our move, because otherwise they get pulled way too fast. All right, then finally, the remove condition. If the location, if the distance between the source block and the location is less than 1 block, then we want to remove the move with cooldown. All right. Well, congratulations. We have created a move using a state machine, temporary blocks, and moving entities. Now let's just return the proper location in the onLocation get location method. This is it. All right, I'm gonna start my server, and I'll see you guys in a bit. All right, hi guys, I'm back. There was a little thing that I forgot. I didn't call a start method in the constructor, so the move wasn't starting. So don't forget to add that. Once you got that going, I'll set you up on this ledge so I could pull you off. And what do? You fall off. All right, so you sneak at water, hold sneak, you look up there, click an entity, and there it comes. They get pulled towards the source. Now this isn't gonna work because that pig is in the way. Now it does. So let's pull that one. As you see, when it goes in the water, the bubbles actually show, but they don't show when it's traveling back. So you might want to add that as well. Just spawn particles in the progress pooling as well. It's that easy, really. Let's see if we can actually spawn something on the land here and then pull them into the water, which sounds extremely useful as a waterbender. So we can go like this and click there. Oh wait, it was too far away. We can click and now they're in the water, and you can just do with them whatever you want because they are literally in your element. That being considered, you might want to increase the source range on this a little bit. All right, yeah, I can just push them into the water too. All right, that's it. Thanks for watching, guys. Hope you learned something. I hope next video will be up a little bit sooner because I know this third one took quite some time. I'm sorry about that. I'm trying to get them out as fast as I can. All right, I'll see you next time.